We're going to look at some past circle geometry questions in HSC. So we're going to stay way back in 1996 and start there, eh? So the points O and P in the plane are d centimetres apart. So the circle centre O is drawn to pass through P, and another circle centre P is drawn to pass through O. Two circles meet at S and T as shown in the diagram. Okay, so you need to make sure all that information is in the diagram, and if it's not, I suggest you start including that information in the diagram. So the first thing you need to include is the distance between O and P is D. Alright, so that is distance D. So we need to show that the triangle SOP is equilateral, sorry. Right, so how I'm going to show it's equilateral. You can do this, you can write on your question booklet if you want. Although you do have probably the perfect tool for drawing circles. Hey, it's a clear water bottle, isn't it? Sorry? It's a clear water bottle. So? EO equals OP, we already know that. Yeah. It's the same line, same interval.
So OS equals SP equal radii.
Good. Yep, okay, very good. Alright, so OS equals SP equals OP. Right, I suggest you make some reference to what you're told already. Okay, so OP, okay, which is of course D, and the reason equal radii on all those. Okay, so that must imply that triangle SOP is equilateral. Yeah, because it asked you about triangle SOP, I'm actually going to draw triangle SOP in there. Right, so you need some instrument to be able to draw circles. Nice, tidy, neat circles. Okay, messy circle, just going to correlate some messy diagram. Okay, in there. So show that this angle, the side of the angle SOT, that whole angle there, we need to show it's 2 pi on 3. So what's 2 pi on 3 in degrees? 120. So? So we need to show that it's 120. Should be reasonably straightforward. How are we going to show it?
60. Yeah.
Okay, so angle, let's do SOP, what we already know. 60, let's do, probably doing radians, so pi on 3. The angle in equilateral triangle is pi on 3 radians, sorry. I probably would make mention of the angle OPT, the triangle, so OPT is also equilateral. okay, but we don't need to go and prove it, all right, because it's not asking you to show two triangles as congruent. It's just asking you to show the side of the angle SOT is that. So triangle OPT is congruent to triangle SOP. Alright, so let's assume knowledge at this point, the triple side test. Okay, so remember in intention 1, your mathematics knowledge and skills are assumed knowledge, unless they're asking you directly to show something, okay? So that means implies the angle POT, angle pi on 3 as above. So therefore, angle SOT is 2 lots of pi on 3. Alright, hence, alright, keywords. Alright, so you need to look at these keywords. It is saying hence means you are given what information, just about all the information you need. Okay, so you need to be able to use that to show the area of the shaded region and the pi. Can you do that?
Yeah.
Well, yes, you can. The area of a?
Sector.
A?
Sector.
Nope. Sector if you're cutting out a slice of cake or pie.
Shaded region.
Yeah, it's gonna find it.
What's the other thing we did? We did the sector, and we also did the...
Portion of the sector, whatever the word was, how you, yeah, that thing.
What?
How you did the triangle, and then there was two separate things. I know what it,
You know what it looks like, you don't remember what it's called.
That thing.
You're finding that, aren't you, essentially?
Oh, yeah.
Which is the...
Triangle, the...
Yep, which is called the minor...
Minor sector.
No. That's...
Region.
No. Minor segment. Alright, so we're essentially finding two of those, aren't we? Okay, so what's the formula for the area of the minor sector? Thank you, minor segment.
Angle over entire circle
Yep.
equals
That's for
segment over entire
that's
area.
for a sector though, not a segment. Okay, this is the area of the sector, which is pi r squared theta. Take away the area of the triangle, pi r squared times sine theta. Okay, that's how you need to remember it. Or how, so you need to remember that. That is one way to do it. Okay, so how do I need to modify that so I can answer the question?
Change R to D and D to triangle.
Yep. What else do I need to consider?
That
Yeah, okay, because you're just considering one circle, you'll find one of those minor segments because of what was shown before with everything being congruent and the circle have equal radii, okay, so we need to double that area.
would we lose an entire mark or just lose half a mark for doing that?
You don't lose, you don't get half marks of either 1 or 0. Alright, there are no half marks in your HSC. Okay, so this is what, 5 was it? 5 overall. So that will be 1. That will probably be 2. And this one will be the other 2. Okay, so you get 0, 1 or 2 marks depending on what you've shown. Okay, so you need to double it because of your finding two minor segments. Okay, so that will cancel there. Right, so equal d squared 2 pi on 3, take away sine of 2 pi on 3 because that's the angle that gets formed at the centre.
Wait, where's the d squared?
Hey,
Ah, I thought d was diameter. Why did they do that? Didn't they pick like
Yeah.
X or something?
just to show you off a little bit.
D.
Alright, so 2 pi on 3 is 120. So what is the exact value of sine of 120?
That's a very good one.
180
Yep. So sine 120 is going to be the same as sine 60, isn't it? Because it's in the second quadrant. Okay, so remember, all students take calculus. 120 is in that quadrant. So an angle in that quadrant is represented as pi, take away the basic angle. Okay, so that basic angle is 60 degrees. Okay, so therefore sine of 120 is the same as sine of 60, right? Which makes sense because if you think about your sine curve, you've done sine curves before, haven't you? Yeah, okay. So that's 90.
Yeah, only just got it like that. Only recently clicked and we're doing it for
Yeah, like
a
last
really
week.
Yeah, well, I think we're doing it at some point this week, mathematics too.
finally clicked for us. So.
I'll show you how the sine curve works. Right. So that's sine 90, sorry, so 30 degrees that way is going to be exactly the same as 30 degrees the other side, okay? So that's why it works. So what is the exact value of sine of 60?
Pi on 3. On 2. 3 pi on 2. Why did I say pi?
Why did you say pi?
What? I've had 3 hours of sleep. I've been awake for 4 hours now. Well, I'm not going to get an hour, but some marks.
Root 3 on 2. And that'll do. Okay, no point expanding out. Alright, so that'll do. In terms of D, find the area. Alright, this could be one of those questions where they're allocating the mark for your units. Okay, if you don't include those units, that could be where you lose your mark. Alright, so make sure you have those included. Okay, not a bad 5 marks though.
Oh, that's
Once you sort of get your head past what's happening and not having your freak out moment, right? It's not too bad.
we do circle geometry and extension too.
Yep. Yep. Harder style question. They may seem harder, but it's just one of the things that when you see it, it just looks really simple. But we'll worry about that when you get there. Now, the other comment, now that 5 minutes reading time is very important, particularly for these styles of question at the start of your assessment, okay, because I would be spending, or obviously look through the whole exam, get a feel for what's going on, okay, but you can use those 5 minutes to start identifying what you need to do for your geometry style question, okay, so you can start looking, just have your exam, and you've got your 5 minutes, okay, I'm looking at this, minute or two. Right, so I'm going to show equilateral. We're going to be able to see that the radius is the same for those points. Therefore, I can show that 2 triangles are congruent by just writing a statement and then show that the angle is that. And then finding the shaded area, well, I can see that it's going to be 2 minor segments of the same size. All right, so I'm going to use my minor segments formula and double it. Okay? So that's, and then when you get to the question, you've already thought about it, or if you don't quite have the response yet, at least it's in your mind, you're starting to subconsciously think about it, okay, and then when you get to it, hopefully the idea is that you have a much better grasp of what you need to do. Right, next question. You're picking? The circle geometry is in every single HSC exam. Okay, the only one was 2010 or 2009. There was a circle geometry question, but it wasn't this style. It was more using calculus to do other things, but using some circle geometry properties. Okay, so we'll look at that when it comes.
We've done a lot of these.
Yeah.
Like,
Yep.
I don't think we've done that one. Let's do the last one.
Yeah, because that was an exam just finished.
Oh, okay, let's do that one.
Yep. Alright, the one just finished. I don't actually look through the whole paper yet.
Poison their water. You get everyone.
Right.
It's like a microphone, you get angry.
Right, so let's try this. So you're having your 5 minutes reading time. You're flicking through your paper, okay, and then you come across this question, okay. So I would think maybe in the whole thing you probably want to spend about a minute on this. All right, spend a minute. Actually have a look at it and work out what we're going to do. All right, before we start answering it. Okay, you can look at your own if that's too small. CAD.
So BCY is going to be 6 meters, and BCB is 20.
That's the sort of stuff you can.
BCBD. What? What did you just say? BCB. I know what you're getting at. I know what you just said. You said BCBD.
I can't remember.
So that's 90 degrees, and because you could just do angle sum of a cyclic one, and that equals 180 take away. What is it? Basic. Alternate angles are supplementary. Yeah.
ABX is
So 100 to 90 take away. Yeah. So BCA is 60. ACB is 60.
ACB.
Yeah, ACB is 60.
Because BAB is 90, and then angle sum. What
Angle,
are they called again?
angle of semicircle is
You know, and then opposite angles in a cyclic quad are supplementary.
But that's the first question anyway.
And then ADX, you just moved on to the second one. Good on.
Fine, give reading time. Okay, so noticing these things here. Okay, so the 1 mark questions, you don't need to do anything extravagant. Okay, you should not need to do anything extravagant for 1 mark. ACB.
So what we have is a right angle.
What? No. ACB, that one.
BCB is going to be right on 20 on the top. Why do we go over there when we do that?
What?
BCD is going to be a right angle anyway.
Yes, that's it.
Yeah, okay.
Well, I went to the
Good.
other side and looked at that.
Good, so you've identified where the right angles. Okay, so a couple of things. So one, you've got a diameter, use that, or radius, use that for 2 different applications of right angle. So the first one's here and here. Where's the other application of the right angle? The radius is perpendicular to the tangent. Okay, so that means these 2 are also 90 degrees there and there. Okay. Now, the second thing I've observed is that there is a tangent. Okay, so there must be a reason why they put the tangent there. So you need to think about your tangent property, particularly the one that comes up very often, which is that one. Do you remember?
Angle, external angle is equal to the angle in the ultimate sector.
Yes. Okay. So, remembering that the angle formed the tangent and the chord. Okay, so you take that chord and then you pick a point on your triangle, all right, to join the end of those 2 chords, all right, those 2 angles are equal.
Why not just do it down the bottom?
Yeah, or it works that way. So you can do So you've got that chord there, you pick that point there, alright, so that and that, okay, it equals that angle there. So that means that angle must equal that angle. Which is also your butterfly wing concept there, isn't it? Yeah? Yeah, okay, so it just depends on how you see these things. Alright, so it also works the other way. Alright, so you take the tangent, there's your chord, angle between the chord and the tangent. So you pick a point, okay, so let's say if we pick that one, join the end point of those two chords, alright, and that's the angle there. That's equal with the angle between the chord and the tangent. Alright, so you need to remember that one. That one does come up a fair bit. Alright, so we've established that angle BCD is the right angle. So from that we should be able to state what the angle of that. So the question is saying what is the size of angle ACB? Okay, so that means you need to do a proof to justify the size of it.
Oh, no.
Okay, it's not asking you to do that, therefore you don't waste your time and showing that this is the right angle because of this property, therefore 90 take away 30 equals 60, therefore that angle equals 60
So
degrees.
you just write I 60 degrees.
What's the size of angle ACB? That's all you need to do.
What?
Okay, what is the size of it? I don't want to know how you get it, I just want to know what size you got. What is the size of angle A? The other thing is, you should always label this information as you go. So in your copy or trace, when you copy or trace this diagram into your books, alright, you should be labelling these things as you go. Okay, and then even just labeling that 60 degrees there, I can do a couple of things with that. Okay, I'll be able to straight away tell what that angle is there, and also do a quick calculation for the angle here. Okay, just based on that information being included in the diagram. Okay, so what's the size of that angle? 60, because it's the butterfly wing. Okay, what's the size of that angle? 20. Angle sum of the triangle.
So 3 is 70 degrees.
So,
3 is 70 degrees. Last question, 70 degrees. 9
yeah, yeah, good. Right, and then from that we've got the last answer already. Excellent. What'd you say?
Why aren't we a year earlier? This isn't easy.
Because that's why I went through everything in your prelim course, that when you do it again in your HSC course, you've learnt them, you memorise them, you have a different perspective on this now, okay, and often the case, as you've just demonstrated, you can see these things much more quickly than what we used to be able to do. Okay, and hopefully our circle geometry questions will be done very well. Okay, because I know you either like it or you don't. Okay, so one of my favourite topics in extension, I do like it a lot. Okay, but there are the odd question that will stump me, but I'll take it as a challenge. Alright, so what's the size of angle ADX? ADX, that one. Okay, 30? Because?
Opposite internal.
Hey?
What's the
Yeah.
Exterior angle.
Well, it is the angle between the chord and tangent. Is equal to angle in the alternate segment, isn't it? Because here's your chord. Alright, if I pick that point and join your end point of your chord to that, okay, those two angles are equal. Okay, so pretty simple 2 marks out of 70 so far. Alright, so I'll label that as well. And find, given reasons, the size of angle CAB. Okay, so Michaela has justified is the right angle all there. Okay.
So, maybe.
Now, this is of course not the only way you can do it. Okay, I'm sure there's going to be more than one way. You probably will come up with a different way to answer that question. But as long as you can justify it, and looking at your mark, 2 marks, so I shouldn't have to do too much to justify it. But can you see an alternate way I could answer that question?
Yeah.
C, A, B.
What I did was AYD equals 100 degrees.
So,
I did
AYD 100, yep.
Yeah, and then from that, angle sum of the revolution, BYA equals 2 times BYA equals 360 take away 200. Which is 80.
Yep.
So BYA equals 80 degrees.
Mhm. Okay, I personally would, another way I would have done it, this is 80 degrees here, angles on a straight line. Okay, angle between the chord and the tangent is 30. Okay, so there's another way you could do it.
Yeah. Yeah.
Yeah, I was trying to figure out, like, how do I figure out that little angle? Seems so
You're
hard.
right there.
Okay, so the approach is certainly different there. Okay, in 3 different ways we've done it. Right, but 3 ways will work as long as you've done the correct setting out of your proof. Okay, and having an answer.
I see AD. Could you just say BAD equals 90 degrees and then take away the 20?
Say it again, sir.
BAD equals 90 degrees, so we've written that down. And then because CBD equals 20, is 90 take away 20. So that angle equals
Yeah.
20. And
Mhm.
that
Yeah, that's the way I do it.
Yeah, that's the way you can do it, yeah.
It's so easy.
That's what I'm saying.
Why is this so easy? Ah.
Well, it's just like I said, we've gone through this, I've hit you hard really early, okay, and your results are coming through now. Okay? Now I won't write a proof because they're all going to be different, but you've got to make sure giving your reason. Okay? So whatever you state, you need to give a reason, alright? However you do it. But, next question.
I'm going to go.
Yes.
I can think of
When you got here, like, half an hour ago.
40 minutes ago. Exactly.
Alright, well,
5 minutes.
you want to do another question or you have enough?
I think I've got the hang of it.
Alright, so for next lesson, can you can probably do it when you come in and have a look, but we'll do some more questions out of that. Okay, I'll give you a working lesson, first lesson next week. Alright, so we'll set most of the rest of the assignment depending on how much we do in class as past questions for your HSC.